Wir sind in Korea und in diesem Moment, wenn ihr das Video seht, dann steht Felix auf der Bühne bei der Weltmeisterschaft in der Vorrunde und präsentiert den Coffee Waver oder Coffee Waving. Eine Innovation, die Felix im Rahmen seiner Vorbereitung herausgefunden hat. Wir haben geforscht, wir haben mit Experten gesprochen, mit 2 Professoren und viel getestet und haben immer wieder gemerkt, wie interessant, wie spannend das Ganze schmeckt. Und in diesem Video liefern wir euch Background-Informationen zur Felix-Präsentation. Let's go! Wir sind in Korea, jetzt gerade in unserem Hinterhof, aber eigentlich findet jetzt in diesem Moment, wenn ihr das Video seht, auch die Vorrunden-Performance von Felix statt, denn der ist deutscher Barista-Meister und präsentiert oder repräsentiert Deutschland hier an der Weltmeisterschaft. Und mit diesem Video geben wir euch Background-Informationen. Wir als Team, bestehend aus Nicole, Coach von Felix, vielfache deutsche Barista-Meisterin, aber weiß ich gar nicht, ob vielfach. Wie oft hast du gewonnen?
Aber
Coffee in Good Spirits hast du gewonnen, Brewers Cup hast du gewonnen, international warst du auch erfolgreich.
Kaffeemeisterin.
Die Fachkompetenz schlechthin. Und natürlich du, Felix. Und hinten im Raum sind noch Jael, ganz wichtig für unser Team, außerdem David, die das Ganze hier mit möglich machen und eben auch möglich machen, dass du jetzt hier auf der Bühne stehen kannst in dem Moment. Wir wollen euch ein bisschen Background-Informationen geben. Denn ihr habt was rausgefunden oder du hast was rausgefunden, du hast es bestätigt und wir sind dann tiefer reingegangen, nämlich Coffee Waving. Was ist das? Wie bist du da hingekommen?
Wie ich da hingekommen bin, also weiß ich im Nachhinein auch nicht mehr so hundertprozentig. Ich hatte mir für die Vorbereitung so ein bisschen überlegt, welche Themen finde ich spannend, weil ich finde, es gehört dazu, sich irgendwo so ein Rabbit Hole zu suchen, in dem man ein bisschen tiefer graben kann. Und dann habe ich da einen anderen Teilnehmer letztes Jahr gesehen, der hatte eine Vibrationsplatte zum Distribuieren seines gemahlenen Espressos. Und ja, das Thema fand ich irgendwie spannend. Dann habe ich mir mal so eine Vibrationsplatte gekauft, habe das dann auch ausprobiert, den Siebträger draufgelegt vor der Extraktion. Und das hat mir überhaupt nicht gefallen. Das war totaler Quatsch, meiner Meinung nach. Das habe ich sofort sein gelassen. Und dann stand ich da unten in unserem Trainingsraum in dem Keller und habe überlegt, was könnte ich denn damit sonst noch machen? Und dann habe ich gedacht, ja, ich könnte doch einfach mal einen Espresso draufstellen und gucken, was so passiert. Und als ich dann die richtige Dosierung der Vibration gefunden habe, dass nicht alles oben rausgesprudelt ist, habe ich es probiert und habe gemerkt, der Kaffee schmeckt besser. Und dann war ich so ein bisschen verwirrt. Denke ich jetzt einfach nur, das ist besser oder ist es wirklich so? Und ich weiß, es war ein Sonntag und du warst zufällig auch im Büro und bist dann runtergekommen. Und ich habe es dir blind gegeben und du hast es auch geschmeckt, dass es besser, anders, dichter schmeckt. Und warst dann auch ganz aufgeregt, hast direkt den Chahan angerufen.
Ja, zu dem kommen wir auch gleich, weil bei dem war ich dann später in der Universität bzw. an der Fachhochschule in Bern. Das ist der zweite Teil dieses Videos, denn wir haben dann noch ein bisschen Research betrieben. Aber erstmal bleiben wir noch bei der Sensorik. Nicole, ihr habt ja die ganze Zeit nur noch so Kaffee getrunken. Gestern haben wir auch einen gewissermaßen Experten getroffen, der hat gesagt, ich will auch nur noch so Kaffee trinken. Ja. Wie hast du es erlebt? Wie schmeckt denn das, was wir da gefunden haben?
Ja, für mich war es eigentlich ganz lustig, als Felix mir die Idee gezeigt hat, weil ich so gesagt habe, ja klar.
Macht Sinn, oder?
Ja, total. Ja. Wir haben tatsächlich Ähnliches auch schon vor ein paar Jahren zu einer Weltmeisterschaft gemacht und deshalb war es für mich eigentlich ein sehr familiäres Feld und ich dachte, ja, ich weiß, wie das funktioniert. Das ist halt einfach eine Partikelverschiebung, wo ich einfach verschiedene Stoffe, die sonst wirr im Kaffee umherschwimmen, auch durch die Temperatur ein bisschen zusammenbringe und dadurch verändere ich halt Textur. Das Ganze schmeckt einfach ein bisschen weicher, runder, more body und ich kriege die Säuren ein bisschen runter. Und fand das so, ja, also schön, dass du das rausgefunden hast, aber das macht total Sinn und total klar. Und dann ist mir erst aufgefallen, dass das wirklich so noch gar keiner gemacht hat auf der Bühne. Also das Thema war einfach noch nicht da. Und es ist super, super, super wichtig. Und ich glaube, das unterschätzen viele Leute immer, dass die Weltmeisterschaften um Innovation gehen. Und Innovation, um die ganze Branche weiterzubringen und besser zu machen. Und ich glaube, da haben wir echt ein gutes Thema gefunden, um das sehr gut auszubauen. Wir haben das ja gestern nochmal probiert. Und da hatten wir auch einen Gast dabei. Und der fand es auch richtig, richtig aufregend, der Sascha Sestik, und hat dann auch gesagt, okay, er möchte jetzt den anderen gar nicht mehr probieren, den normalen Espresso, sondern er möchte jetzt bitte nur noch die vibrierten Espressi probieren, weil die natürlich viel besser schmecken.
Also vielleicht kannst du noch mal kurz erklären, wie genau machst du es? Es geht ja, wichtig ist, und das ist auch ein wichtiges Thema, das habe ich dann eben mit 2 Professoren noch besprochen, es geht ja um Postextraktion, sprich, das Ding ist eigentlich durch, meinten wir lange. Wir haben in der Vergangenheit dann gesagt, hier nochmal rühren oder so lange warten oder
10-mal rühren oder
whatever. Aber dann beginnt jetzt hier dein Protokoll.
Genau, also bei mir, mein Protokoll sozusagen ist, dass ich nach der Extraktion vergehen so 45 Sekunden ungefähr, bis ich dann den Espresso nehme und auf meine Vibrationsplatte stelle. Die ist eigentlich auch nur ganz klein, so ungefähr. Und dann vibriere ich den Espresso für 3 Sekunden und dann ist der fertig zum Trinken.
Das ist es eigentlich.
Also es ist jetzt nicht so spektakulär.
Es ist aber tastable, spektakulär.
Ja,
Sehr. Weil du hast halt die Kombination aus der Vermengung der Moleküle plus die Hyperoxidation an der Oberfläche. Und das macht schon sehr viel.
Das macht sehr viel.
Geschmack.
Und es macht so viel, dass wir wirklich blind in jeder Degustation gemerkt haben, dass die vibrierte Platte nicht nur besser war gegenüber der gerührten, sondern natürlich eben auch über der gar nicht behandelten. Der Kaffee wurde weicher, runder, auch mehr Süße wurde erlebbar und dadurch, dass er insgesamt weicher und runder wurde, wurden auch die Aromazusammensetzungen, das wir erlebt haben, ebenfalls besser spürbar und klarer so wahrnehmbar. Wir wollten es nicht dabei belassen. Wir haben ganz bewusst gesagt, ja, wir lassen diese Idee frei. Wir wollen jetzt hier nichts patentieren oder so, sondern die Kaffee-Community und die Wissenschafts-Community soll damit arbeiten dürfen. Wir werden auch damit weiterarbeiten und dennoch wollten wir hier schon ein bisschen mehr Hintergrundinformationen sammeln. Deswegen haben wir mit Chahan telefoniert. Professor Chahan Yeretzian von der Zürcher Hochschule für angewandte Wissenschaften. Der ist selbst in der analytischen Chemie zu Hause. Hat einen anderen Kollegen angerufen, Professor Dr. Stefan Salentinik von der Universität in Fribourg, der in der physischen Chemie zu Hause ist mit einem Wahnsinnslabor. Und die haben uns eingeladen, er hat uns eingeladen, einen Nachmittag dort zu verbringen und alles einmal durchzutesten. Wir sind also hin und was wir genau gemacht haben und wie die Ergebnisse, ja, da lassen wir am besten die Experten selbst zu Wort kommen und es vor allem auch erklären, denn damit bin ich auf jeden Fall überfordert.
I'm super happy to be here with Stefan Salentinik, professor from the University of Fribourg, and Professor Chahan Yeretzian from the Coffee Excellence Center in Wädenswil. Both helped us a lot with, proving or analyzing some findings we had with empiric testing while vibrating espresso, because we changed our protocol. Instead of just steering, we found out that we have a totally different texture and also a different sweetness when we vibrated the coffee. And I was asking Stefan and Chahan, why did that happen? Can we prove it? Can science help us to confirm our findings? And I think we found some pretty interesting things. Thanks again a lot to both of you for spending so much time with us, and also Stefan, to your whole team, receiving us, helping us, using all that fancy material which you have in your lab. I think this was amazing, and I'm super thankful for that nice afternoon which we spent together. What do you think? Did we have some findings? Can you say or can you tell that the data is proving something of our taste results?
Yeah, so thank you as well. We had a great afternoon together, drinking coffee and discussing science and measuring a lot of cool stuff. So I would say yes. So what we saw with microscopy, with light scattering and other methods is that the distribution of particle sizes when you extract the coffee without shaking as compared to extracting coffee and shaking afterwards is quite different. So our indication is, or the conclusion from the data that we have actually with the light scattering is that the particle size is different, that the particle size, of course, steers the texture, and this gives a different taste at the end.
Yeah, Benny, I think this is really a very interesting observation that Stefan could make. I remember when you called me and you said that you do the shaking and you have like sensory wise, you have a strong indication that makes real difference, you know. And then the question is, we discussed what could it be, you know, what could that be that shaking makes it better? And I immediately thought about emulsion formation, because everybody talks about emulsion in espresso. It could be that in this case, we are influenced emulsion formation just after extraction. And that's where I started to think, and I started to call around, you know, because Stefan is one of these unique experts, you know, in Switzerland who has this experience in colloidal, in emulsions, and also understands coffee. And so as professor in physical chemistry at the University of Fribourg, I called him up because he's extremely well equipped to analyze this phenomenon. And so we did only half-a-day experiments, you know, so to prove and to make it really solid, this requires more. But the data indicate that through the shaking, you create smaller particles in the emulsion, and that there is other papers that indicate that can have a significant effect on the sensory. It can also have an effect on the flavor retention, and many more things can come out. I think this is the start of an interesting phenomena where we might now discover emulsions, emulsion control, and emulsion measurements will be perhaps the big next thing in the future in espresso coffee.
Yeah, I think it was pretty interesting what we found out. And
you see the PDI
much bigger particles?
Yeah, 500
and the PDI.
And the PDI is so big that you can evaluate with this device.
So, okay, so this is now the first test. This would actually mean that it is really bigger. And
why are they bigger?
Because you didn't shake it.
Yeah.
Whereas the one that you shake.
I mean, it's nearly the double.
Huh?
It's nearly the double.
It's nearly the double.
something you always said or you repeated frequently was espresso is not stable after extraction. I think this is pretty much a very important summary of some of our findings, because stirring or vibrating changed the way the particles moved and kind of behaved to each other. Can we dig a little bit deeper into that? Why do you think is that the case?
Yeah, I mean, we have different. So what we saw is different populations of particle sizes. So different sizes of particles, let's say, in the espresso after extraction. We saw sizes of 300, 400 nanometers, so very small, which we think that it's oil bodies that are extracted from the coffee as emulsion particles. Then we have larger particles that go up to a micron, so particles that you can actually then see with a microscope, because the very small ones are too small to be seen with a light microscope. You would need electron microscopy, and we use light scattering as a very beneficial statistical method, because it gives an overview over basically the whole statistics that we have in our volume that we tested was a milliliter of coffee. So we get a very relevant information on what is in the espresso in terms of particle sizes. And then, of course, all these particles move around. It's Brownian motion. You see in the videos, they are really alive in a way. And they collide with each other, and with time they grow, because these collisions can lead to a melting of two particles, or we have pressure differences, more complex things, but over time, the particle size grows. So the espresso changes over time. And we saw that this is actually quite fast. Within minutes or even sub-minutes, we see changes in the particle size and the distribution, which I think one can taste. I'm not that good in sensory, like tasting differences, but someone that is really well trained like you, I'm sure you tasted the differences as well then, that we saw, like with the more scientific kind of instruments looking at the meso and nanostructure as well.
Absolutely, the difference was absolute obvious and really easily not only recognizable, but also repeatably. You saw it time over time, and after time, it was always the same result. We feel that other texture, we feel that other sweetness, and the empirics, the sensory sides was pretty obvious. And yeah, it's really interesting to also find it kind of proven in the data. Chahan, you said maybe we have to look even more into the phase after extraction. We create kind of an emulsion, but maybe it's not in the status yet, or maybe we didn't research enough to about the part after extraction. Maybe we can go a little bit deeper into that. What do you think? What are the next steps? What do we have to research to understand even more what to do with an espresso after the extraction, and why is that the case?
Well, I think we did it quite fast, in the short time we had. But I really think the first element of research on emulsion is to develop an instrumental, analytical basis, a platform to properly measure emulsions. Emulsion size distribution, emulsion dynamics, but also the coating, because every particle, every fat particle has a coating which stabilizes. So I think we have a lot we can improve in terms of measurements. The second element that we need to understand is what should an emulsion be in order to have a good sensory profile. So first is measure. Then the second is where do we want to aim? And then the third trick is how do we treat it? How do we go from where we measure to where we want to go? So this is, in fact, a huge new field for me, where a lot of experts like you have to define a little bit what really is an optimal situation, that we have to understand then also instrumentally, and then understand which type of treatment leads from where the espresso comes out to where we would like to bring it. We also would like to make it more stable. I think that this shaking or vibration could also stabilize the emulsion and keep it over a longer time. So there are many things. I think we're at the beginning, but really this concept of measure, aim, and treat is really what we have to do. And it's like the start of the era. Everybody tells coffee, especially emulsion, but we know not enough. And I think you are triggering something. And it could be connected to many other things that people observe and never mention, We will find that out.
I'm pretty sure that this is a way to go. And when I now think back also about some espressos I drank in the past, I'm asking myself, was it really bad distribution? Was it really a problem of extraction, or might be the problem actually be the part or the time phrase after the extraction? Maybe the temperature of the cup, maybe not proper steering, or whatever. I think there's a whole world of things we have to look into because this was pretty obvious. The coffee is not stable. It's not done yet. It's not finished till the moment you drink it. So I think we really have to look more and more into that phase. And I think all that questions we asked in the past, how long staying, how long staling, all these are questions we have to research again, not only by tasting but also by science. Stefan, I would like to go back a little bit. Could you summarize again which kind of machines did we use? And which machines gave some indications and maybe which ones not. But I think this is also something really interesting for all the followers and people which are watching the video right now. What did we actually do after extracting the espresso? What was our kind of protocol which we used and which kind of techniques did we use?
We started with microscopy. We did Raman microscopy, which is a very nice tool because we can not only image kind of particles, at the same time we can get the composition of the particles inside and outside and different locations of the image. So it is a very nice compositional imaging method, so to say. But of course, it's optical microscopy based. So we don't see particles that are below, let's say, 500 nanometers in size. So what we saw is large, like emulsion particles floating around, oil inside, stabilized. We still have to figure out and analyze this in more detail, what the composition of the shell, of the core, of the outside is, and so on. And then to analyze smaller particles, we went to light scattering, which is actually very difficult in coffee because of the color, and we use lasers and so on. and it should not heat the sample as well, because otherwise we get artifacts. But we managed to develop a protocol that we could actually measure particle sizes in coffee. And we saw that the majority of the particles is actually smaller than what we see with the microscope. We see the same size that we see in the microscope, but then there's a population that is even smaller, which we assume is extracted oil bodies from the coffee, which would make sense. We saw this from other seeds where we can extract these structures, which are emulsion particles as well. So we have different populations, which is very interesting. Then we also did X-ray scattering. So we were shining X-rays on the sample, and it's an indirect method, analyzed the scattered X-rays. Also there we saw particles in the range of nanometers to micrometers. So very interesting data, different methods, all indicating, or all at the end showing within an afternoon that we have particles, that we have emulsions in the espresso after the extraction, and that this changes because we did time-resolved experiments, so at different time steps after the extraction, where we actually saw the change in particle size that you mentioned before, which is also very interesting to discuss and to analyze further, of course.
Yeah, and we looked into the differences of not steering with a spoon, vibrating, and then we used even ultrasound and 2 different methods of ultrasound. We saw also something there, but then we interpreted again that this might be also the gas, the CO2 brought into the solution. Or could you summary for me the results which we found by ultrasounding?
Yeah, so what we did is with this ultrasonication, with the ultrasound, is basically we bring in a lot of energy into the coffee. And this energy, of course, disrupts particles. It mixes the solution, but it also disrupts particles, larger ones, and makes smaller ones out of the large ones, because you basically have an emulsion that has a certain energy. The droplet is oil, like floating around, a certain size. And then you put a lot of energy in, and this particle breaks up into 2 or 3 or even more, depending on how much energy we bring into the system. And with our high energy sonication, we completely changed the texture and the sensory properties of the coffee as well. And we saw with the analytical methods that we changed the particle size, as we hypothesized before we started the experiment, because we said, okay, if vibrating gives a certain energy, what happens if we increase this energy and basically go brute force with this ultrasonication device?
Yeah, and we drank a lot of coffee. It was a nice afternoon. Many people of the university, of your faculty, came around to have an espresso. So we enjoyed also the afternoon. I think also this is a reason to continue with that research, so that we have some nice coffee together. Can you give some hypothesis? Where does it lead to? What do we have to figure out next? What could be the next steps? Maybe some ideas in that direction.
Just first of all, I think we had a hypothesis, and it seemed to be correct. Of course, it's only half a day experiments. We did that, so we see that the shaking leads, or the steering, or then the intensive shaking gradually decreases the size of the smallest nanoparticle size, nano-sized particles, which we assume are fat globules, emulsions. So, and that would indicate that in the mouse you get another feeling, and we saw that, and so that's very interesting. The second for me is, as what you said already earlier, Benjamin, is that we are kind of shifting our focus to post-extraction phenomena. We have spent so much time trying to understand the extraction, and there is a lot happening post-extraction. And so we have introduced other tools and observed other phenomena. And I think it's interesting to see that, again, after extraction, there's a lot happening, and which can improve the quality of espresso. I think that's my takeaway.
From my side, I fully agree. The very interesting part is this link between composition at the end that you get in the coffee, and then we have a structure, and then we have sensory properties. No? And here we have the composition is the same. The composition does not change when we change the particles or when the particle sizes change over time. It's the structure that changes on the micro scale, on the nano scale, and that gives completely different properties, sensory properties. And this is not analyzed at all. This is a field of research that is just starting, because traditionally everything is based on composition, but now we more and more realize that the structure plays a role, and the structure, even at the larger, not only macroscopic, microscopic and nanoscopic is important in this sense for physical properties and sensory properties. So that was very, very nice to see with the coffee experiment.
To both of you, I think I'm super thankful. I think the whole coffee community is super thankful. And I know that there are many people in the coffee community which are also interested in science, but also in chemics and physics. So I like to invite you to use that window to do a little bit of propaganda for your faculty. What are you both doing? If someone likes to combine studying and researching and coffee maybe in the future, why should they apply in your university, or what offers you on university? Stefan, you like to start?
Yes, I mean, to start with, we are fascinated, and we become more and more fascinated about coffee. Also with you and your input and all the kind of new work that we get linked to now, where we can use our tools, where we can use all the physical chemistry and the equipment, the fancy equipment that we have to analyze things that no one else analyzed and saw before. And that's what we are passionate about, emulsion, stability, things that are very small that you cannot see, but that have a huge impact on properties, on taste, on materials, related to coffee, related to food in general, nutrition, all the flavor compounds that are released depending on size of particles, structure, and so on. And you can actually feel it, you can taste it. That's the amazing part in the coffee world. And it keeps you awake as well.
Keeps you awake. And also Fribourg is a beautiful city. I will link your university down below the video so that people find you and your work. Thank you so much, Stefan. Chahan, you are already researching many years with coffee in the Coffee Excellence Center. I'm pretty sure most of the people know you, know your work, and also the ZHAW. Nevertheless, if someone doesn't know about you and your work, what should they know in the future?
We are a center dedicated to research on coffee along the whole value chain, from sustainability project, nudging countries, all the way to coffee tastings and everything in between. Because the special thing with coffee is that everything is connected. You cannot really understand extraction, you can understand coffee origins or the sensory. You have really to connect everything to understand even elements. So the zero thinking is not something we should, which is very helpful in coffee. And, so that's one of our objectives. And, we work with a lot of companies worldwide. And I think we have, I'm just one person in the Coffee Excellence Center. We are many people who are doing excellent work over the many years. And we also, over the last, I would say 3-4 years, have realized that research is important, but education is actually also very important. People now are asking more and more about education programs of things that we already know since a long time, but which is not disseminated. So we are now pushing education program postgraduates. To answer also to Stefan, I think an element that is neglected is definitely this texture of the structure. People always connect composition to properties, because it's like you look there where you have techniques, you know. But another field that we worked recently, and it's like a preview into a paper that will come, is roasting. Roasting depends very much on the bean structure. You know, we always research on the composition, on the precursors and the roast profile. But if you grind the green coffee, you get a totally different flavor profile. The texture is fundamentally important because of the microreactor composition. And so we did a whole project on different rice, different, like very coarse to very fine, and looking at the formation of flavor. So I think that's another takeaway. And I think with people like Stefan, texture in coffee is a very important element, neglected. And perhaps also because we don't have yet the experts in the techniques. I don't know. And that could be also something that I would like to further pursue with Stefan in the future. I would like to wish you a lot of success during the World Championship with all your knowledge, expertise, and I think now more than 10 years or 15 years of experience in this field, in the world of specialty coffee. You deserve it to really perform well. I will be observing, watching from far, and I wish you all the best.
Thank you so much, Chahan.
Hey, I wish you all the best too. I hope you manage to kick it out.
Das war's aus Korea, das war's aus Busan für den Moment. Wir erfahren dann noch, ob der Felix übermorgen im Finale steht oder im Halbfinale erstmal. Aber so viel zu diesem Thema. Drückt uns die Daumen und wenn ihr uns verfolgen wollt, Nicole auf Instagram, Felix auf Instagram, mich auf Instagram, aber natürlich auch unseren Kanal auf Instagram oder sonst wo, guckt einfach unten, alles ist verlinkt. Da erfahrt ihr auch noch mehr über die WM und natürlich auch über diese neue Innovation, den Coffee Waver bzw. Coffee Waving. Danke, dass ihr wieder dabei wart und ich würde sagen,
Time!